This is a kit I put together for Boy Scouts. Um, we were sharing with them our model train, and I wanted them to have an understanding of some aspects. I wanted them to see one of the model trains running, and I wanted to give a little bit of an education on electricity if I could. So I created this display, and it's powered by a transformer with AC coming in. I'm measuring the AC amps as it comes in, and this is the on-off button. You have to hold it to get the engine to run, okay? But the other thing that I did, and then you can see what are the amps going into it, something like 1.25 or something like that. But then you can also turn off and on some of the accessories, like the headlight. We can turn on the headlight and see that the amps have gone up a little bit. We also have the smoke on this particular model, and I can turn the smoke off and on. And when I turn the smoke on, we'll get smoke in a few moments. Did I not get it all the way? Should be. Now we're up to 1.6. And we have smoke popping out. So you get an idea of how the train operates, and also some of the nuances. This is an electromagnetic reversing unit with a drum inside there, and when I click this, you'll see that the little drum moves, and that changes the contact points. There's one direction, there's a neutral, there's another direction, there's neutral, there's another direction. So we have what we call a four-step electromechanical reverse. The engine in this particular model is an AC motor. It's actually a universal motor. It runs on AC or DC. So the brushes and the fields are wired through the same circuit, but they are reversible in that you can reverse the direction in the fields, and then that would change the direction. Inside here is what's called a brush. It's a little piece of carbon with a spring, and the electricity goes through that to this armature, and it rotates and changes the position of the fields. And then these are fixed fields. This magnet electric coil creates electromagnetic fields, and it spins through those fields, changing armature positions and creating rotation. This is a gear that comes off the drive shaft, and it pushes a piston in and out in and out of the smoke chamber. And in here is a heater and some oil that creates a boiling smoke. And when the piston is pushed out, there's a little hole that pushes it out and comes out. That hole also creates a small whistle-like sound that we refer to as chuff. So you've got chuff, mechanical chuff, and a puff with the smoke. You've got an AC fields, which are actually magnetic, but through a coil of wire. And then you have the armature and brushes that change the rotation or maintain the rotation if it's set in a given direction. Then you have the electromechanical reverse, and it's all driven by a transformer similar to this American Flyer 15B, and you have base 7 to 15 and 15 volts for accessories here on the far right, and it is as you can see it up here, 110 watts at 110 volts. So this is a very basic how the engines work, the components within them, and what we're doing today. And I'll take a short pause and come right back and show you that. Okay, I'm back at my other bench, and I've put together some stuff that I want to share with you as background onto what's going on. This is the piece of track. It's wired into the transformer. It has one rail for the common, and one rail is for the 7 to 15 volts, which is typical on the American Flyer train sets. Okay, in these rails then power is picked up by the tender, which is usually the or a pair of pickup wheels. It could be a number of variations, but in typical steam engine you have a tender and a steam engine. The tender wheels pick up the power, and they bring them up into the body of the tender for distribution throughout. And we have various tenders around I'm going to share with you in a moment. The power as it comes in is AC. One of the changes that we've made to the motor from the original is the field sets. We've converted them to permanent magnets using a 3D printed part. We have a field housing that I've designed, and we print it with a 3D printer, and we place a pair of arc magnets in the slots, and then we have some booster magnets on the side, give it a little extra oomph. And this creates the magnetic field that the armature switches through when it's going through its rotation. Power coming in through the brush is the same as the universal or AC motor, but now with permanent magnet, it's seems to have more response and a little more reliable, and it certainly is less space and less weight. Weight sometimes you want, but in this case we needed the space. And this one I've added some all-thread inserts so I can mount something on top of that. To get the power to the engine, the first thing we have to do is convert it from AC to DC. We're doing that now with rectifiers. Here I have a pair of rectifiers, and there's a reason for that. I've split one rectifier to provide power for the smoke systems that we use, because there's a heater involved, and that really takes a lot of power to run that heater to create the smoke. Then we also have our motor controller and our sound system, and they're on a separate rectifier, so they just get different versions of the converted AC to DC. I don't have any conditioning in here. We did initially, but I had trouble with the digital reverse board, because just like the mechanical, where there's a neutral, reverse, neutral, forward, neutral, it wasn't able to switch out of neutral smoothly because there was some leakage going through or some storage in that capacitor that kept providing power, and we were having trouble with it. So I had to take that capacitor out of that circuit. That may be something that I need to change as we go down this path of what's going on and what's my problem, because I have two problems. So this is one area that we think we want to work on, and there was some dialogue on another project where I needed a bridge to get a clean signal out of positive and negative DC, where they thought some people recommended a capacitor and a resistor to kind of help smooth that out and keep it down. There may be something in that idea that would help me with this power here, because I got a couple of things going on. I'll explain that as we go along. The engines, typically, like we saw back there is a chassis, there is a motor, and then there's a smoke system. And then in this case, this is the vintage Flyer smoke, where there's a gear moving the piston in and out. One of the things that I've worked on was this housing was always a problem to work with, and I've created a new type of a lid where the heater has a thermistor next to it, and this chip over here is managing the volts going into the heater based on the temperature, so that we don't overheat and use too much oil or underheat and not have any smoke coming out. So I can dial that in once we get cranking, and this will help that out. The other thing I ran into was trying to fit an older engine that didn't have this particular setup with the holes and where the vintage smoke could be mounted. Also, we were running out of vintage smoke units because they don't make them anymore. So I worked on a design for a smoke housing to replace the vintage smoke that would also fit the Flyer machine, because a lot of the third-party smokes like Lionel and that, they were more vertical, and they would sit up and they would take too much room, and you'd have to grind a lot of metal out, or you just couldn't fit it at all. So I worked on this design for quite a bit of time and came up with it. It's just called a linear smoke housing, but in any case, so that it works. It has its own lid. I have a version here. Here's an older version of the lid that would bolt on here, and the controls would sit out the back. There would be a fan-driven smoke, so that it would have a motor and a fan bolted onto the back of it, and it would be pushing the smoke when it was given a pulse. So now we got an electric motor we have to pulse. We didn't have to do that here. We had a gear and a piston going around. So now we got to pulse an electric motor to get the smoke. We have to provide heat in an environment to create the heat to make the smoke. And then we got this chamber. Now we got to mount this chamber on this engine, which didn't really seem to be too compatible. So I came up with the notion of an adapter, which converted the bolt pattern of the vintage smoke to one that was more useful for my smoke. Then there's an older version of the engine, even older, that didn't have smoke at all. There's no gear, there's nothing, there's no place. So I came up with an adapter for it where the vintage, the new plastic smoke would bolt on it and it would work in that way. So I have the same smoke now for both, and then the same lid fits, and that can be used to work with it. So that's one of the areas that we worked on and we solved, along with the motor. The challenge was in the electromechanical reverse. A lot of problems with that over the years. I've had numerous of them, and I finally just wanted to quit. I didn't want to do those things anymore. And there was a Lionel PC board that you could get from the late 60s, early 70s. It was called the 0103 Lionel Digital Reverse. They stopped making it. They were $9, then they went to $12, then $16, now they're $20. Well, if you can find them, they probably can't find them. And they tended to burn out. So there was a white paper written in the 80s, I believe, and we found a copy of it where an engineer reverse studied the schematic and created with all of the information necessary to recreate this PC board. So we did. We designed the board. We put all the parts in it that he referred to, and we made one. And it worked, and it burned up. We determined what was going wrong with it, and we increased the capacity of that component, and we ran it again. It burned out somewhere else. We inspected that part. We replaced it until we had a fairly robust working system. We increased the size of this capacitor. We increased the size of the transistors that were running the reversing power switching, and I think there was another piece or two that we beefed up. In any case, it's very reliable right now. It can run up to 6 amps. We rarely see more than 3 anymore, so there's a safety factor involved, and it's robust. But it still uses a logic where we drain power in neutral, and then it switches to the next direction, forward, and then neutral again, drains power, reverse. And it wasn't draining power when I had the capacitor on this rectifier coming to it. I also put diodes on the soundboard so that we weren't sending signal back. I was thinking maybe it was some feedback coming through the soundboard. Anyway, that's an ongoing issue, is making sure this has a smooth reverse function, and we don't have to delay. Sometimes I had to sit in neutral for the count of 3 and then go to the next direction, and it would click in and take off. And I'm thinking it was just draining power, but we'll have to see what other people think about that. Some of the other boards that we did make were the smoke boards for the various versions of smoke, where we're using our what I called smart smoke. We were just monitoring with a temperature sensor, maintaining constant temperature in the chamber regardless of the airflow speed going about. When it came to adding extra pieces, adding smoke and adding sound, we had to do something with this voltage that was coming in, and it was coming in at whatever the track was set at, and the track can be 7 to 15 volts typically. So at slow speeds you're getting 10 volts, at high speeds you're getting 15 volts, and that was causing havoc with everything. So we put in a buck boost board. Originally had a buck board, and I found my low speed smoke was poor because I needed 9 volts. to run this with good smoke. So we put in the buck boost, set it to 9 volts, and the smoke, it pulls more power at lower speed, it drives power down at higher speed, and this smoke works great. I use that same power then to go over to the soundboard, and it works very nice. In one case, I don't know what's going on here. I needed a fan, so we put in another 5-volt regulator off the 9, and we drive a fan with that, or some other device that we might have. We drive that, and that works well for us. So we're stepping it down, but I'm not really looking at the power. I mean, I have an oscilloscope. I can hook it up and turn it on and watch stuff, and I did look for noise coming through the engine at various times, but I never really knew what I was doing that well to say, okay, here's power coming in, here's what it looks like. What do I need to do to the power to make it better, cleaner, more efficient? A couple of things that are happening is this soundboard is a Lionel TMCC, and it takes a track pulse to turn on the steam whistle and the bell off and on. The chuff takes a constant trigger, and that's what we're using on our new engine here with the magnetic switch and the rotating magnets, and we're creating that trigger for the chuff. So we're getting chuff every time the wheel turns, because that's when the chuff comes out. But on the other sounds, the whistle and the bell, you want to have it come on when you want it to. I have a transformer that has an extra button, and one is for whistle, one is for the bell. And when I push that button, the bell will turn on and ring until I shut it off. On the whistle, it'll blow the steam whistle until I let go, and then it'll stop. And this takes that signal through the track on top of the AC, and sees it and reacts to it. Now, on occasion, I'm driving around, and all of a sudden the bell starts ringing. Didn't push the button. And it'll ring until I either push the real button or shut the train off and on, and it'll quit. So I don't know what's causing the bell to ring. I don't know if that's a high pulse or a low pulse or what it is. And I have two problems. One is it comes on when I don't want it to. And the second problem is not everybody has a button on the transformer. I would really like to have those two buttons in a box that I can do whatever that does and send it to the track and evoke this board signal. Okay? Third problem is these boards are hard to find. They're old. They're as old as the digital reverse, and I'm replacing them with a different board set that I found from a company, Engineering, out west. They're mainly for HO, but they work well. I had a set. They sound good, but I've ruined two of them. And he thinks it's because my power is, I say dirty, but it's pulsing or it's doing something and frying the soundboard. Not the amplifier, it seems to be a little more robust, but the soundboard itself gets it. And that's what triggers the sound to the amplifier. And so what happens is when you turn it on, it's making noise that you don't even tell it to make it, and you can't tell it to stop. So it's like burned into on. So I've done something to two of those systems, and he's replaced them for me. I have to pay for that particular board, but he's replaced them and sent them back with a concern that I need to check my power. I'm regulating it to 9 volts, but maybe that's not good enough. Maybe you've got something else going on, and you need to check your power and make sure it's regulated and it's clean and it's not pulsing or hopping around or whatever. So if there's people in the audience that understand that kind of stuff and can help me, tell me what to do, I can build a system, I can build a prototype, I can put a breadboard together, I can put all of these parts on something, I can hook up my scope, I can hook up my amp voltmeters, and just say, okay, do this and tell me what it says or whatever, and then okay, then let's come up with a better approach to your conditioner. Maybe you do need to add a capacitor, maybe you do need to add a resistor, and maybe you need to add them in a way that the control board is still isolated so that it drains. Maybe it needs something on it that allows it to drain faster for that neutral. I don't know. I can send you the schematics for this board. I can show you in a demonstration. I put something together and show it to you if you want. But my objective is to have these parts, all these parts, released out into the wild for others to make and use and improve the performance of their engines. This is a pre-war American Flyer and a post-war American Flyer. They take the same body, they take the same motor, they'll take the same smoke adapter, so that they don't have that. I didn't grind. This is for the thinner one. Nowhere. There is an adapter for this, so that my black smoke will fit on here. I've had one on there, so he can do everything we're doing, and I want to be able to get to that point where in the tender I can put in the stuff that I need, and I know it's not going to burn something out, it's not going to overheat, it's not going to create a random bell. What's going on? So if there's interest and someone's willing and knows more than me, which is easy to do, I'm not a double E. I've picked up what I know in systems work. I worked in robotics, I worked in medical systems, I built things, I bought stuff and put it together and then invented things around it that made it do what I needed, capturing data or gathering information or moving in a certain way, various things. Okay, so anyway, this is what I wanted to start my day with, because I'm not sleeping well. I want to get this thing resolved. I need this to be rock solid. And all of the other work that I'm doing on the design, the plastic bits and whatnot, it takes a lot of time, and it's stopped me from solving these problems, and I need to do both. One, my brain's not big enough to handle it. I don't have the background, I don't have the core set of skills, but a couple of you guys answered me back and offered some ideas, so I'm going to throw a bigger problem at you. So yeah, we got the little guy here working flawlessly with the diodes now mounted properly and wired in properly. It works great. But a bigger problem is the power conditioning from AC track to DC components. And I can't tell people, well, you got to convert to 15 volt DC and it's got to be clean or the stuff won't work. I can't say that to people. They're just not going to. Everybody I know has a transformer that puts out AC. Few have both. So if I can handle the AC, then I know the DC will not be a problem. We can switch that over. But I got to handle the AC. So if anybody's out there. And looking to the future, this is the system that we're working on today. There's another system, a little hesitant. It's in a box and a breadboard, and it has a microcontroller and a pulse width modulation motor controller. And it's in process of getting built and tested. A lot of the similar pieces you can see. There's the soundboards that I'm working on, the digital soundboards. And one of the issues, one is power, of course, but the second issue is the handheld controller for this thing is killing me. It also has a Wi-Fi, and the two Wi-Fis connect and communicate. So after I get this system ironed out and the 2014 engine done, I'm going to come back to this engine and I'm going to be working on a wireless Wi-Fi solution. I'm going to need some guidance on why this doesn't work and what else can I do to get there. Then, in meanwhile, I'm going to be working with my mini mill, my CNC mill machine, and I'm going to be grinding out these old chassis. I'm going to be grinding out these old chassis to make a cavity so that I can put in my plastic gear, so that I can do the puff and chuff trigger on these old engines. So I'm going to be grinding chassis, trying to fix noise and power issues while I'm finishing this engine's 3D printed parts. And as soon as that's resolved, I'm going to be building a handheld wireless controller. And then after that, there's a whole other bunch of stuff coming. So those of you interested, you follow along, please subscribe, watch what's going on, check me out now and again. We've got other machines we're going to be building, tenders we're going to be assembling, and pieces we're going to be adding, and it's going to be a lot of fun, a lot of challenge, and it'll all be put on a location. I'm thinking Thingiverse for the 3D printed parts. I'm not sure where I'll see where I can put things like the or the PC board stuff. If there's interest in that, let me know. I'll see where I can put that, so you guys can have at it. All right. I would like more people to have this and more people to build it and test it and run it and enjoy the trains to the max. I do. It's fun. And then we'll talk about why a model train and what are you going to do with it? A train's a train. Nope. Not with Internet of Things and everything else we can do. Okay, that's what I'm going to say. That's it. I'm going back to the plastic design stuff, which is a little boring, but I'll let you know how that comes along. Any questions, put them in the comments. Any ideas, let me know. You want to talk to me directly, use my email. I'll put it in there as well. And we will try to figure this thing out with your help. Thank you.